everyone, for today's lesson we are going to learn about factoring and solving polynomial expressions day 2. Day 2 is all about solving. So in our last lesson we learned all about factoring polynomials, and now we are going to take it to the next level by solving them. Our learning targets for today are for you to be able to say, I can solve polynomial equations by factoring. The part about I can solve real-life problems using polynomial equations, that is going to be in a later lesson, so I am removing it from this lesson for today. So when it comes to solving polynomial equations, we're going to use a skill that we learned in Unit 1. And in Unit 1, you learned how to use what we call the zero product property. So we learned how to use the zero product property to solve factorable quadratic equations. And we can extend this technique to solve some factorable polynomial equations. So the zero product property, I just want to remind you of what that looked like. What we did is we factored a quadratic into two parentheses. Those parentheses had to equal 0. And we would have x plus some number times x plus some other number. And what we did is we set each parenthesis equal to 0 and solved for x. And we would get x is equal to the opposite of what we saw on the inside. And then we would do the same thing with our other parenthesis. And once again, we would end up with x is equal to the opposite of what we see on the inside. And a lot of us even skipped this step because we were able to do it in our head. So we are going to be using this property when we are factoring polynomial equations. So when you are asked to find all real number solutions, so we are not interested in the imaginary anymore, so we're just interested in real solutions of a polynomial equations, we need to make sure that we factor completely. So although we might be able to come up with our answer earlier in the process, the skill that I'm assessing you on is being able to factor completely and then setting each factor equal to 0 and solving. You are not allowed to have any decimals in your answer. And so I want to remind you that if we're factoring out a greatest common factor, there might be a variable attached to it. So I need you guys to know that you're going to set any factor with an x in it. So sometimes that x is not in a parentheses. So any part containing an x or a variable, you're going to set any factor with an x in it equal to 0. And you're going to solve for the zeros. You're going to find the zeros, which once again, remember that zeros are x-intercepts. They are solutions. They are zeros of the equation, zeros of the function. And we are only interested in the real number solutions. So nothing that is imaginary. You might see imaginary in your homework that you are going to be working on that corresponds to this lesson. So I just want to put that out there. All right, for letter A, we have 4x to the 5th power minus 40x cubed plus 36x. And just like we did in our previous lesson, we want to factor completely by looking for a greatest common factor. And 4x to the 5th minus 40x cubed plus 36x, they all have in common a 4x, with our leftovers being x to the 4th power minus 10x squared plus 9, and this is equal to 0. So it has to maintain that equals 0 throughout the whole process. Now, x to the 4th minus 10x squared plus 9 is in quadratic form. So I'm going to keep going with my factorization. And I'm going to split apart the x to the 4th into an x squared and an x squared. And I'm going to ask myself, what two numbers multiply together to equal positive 9, but together add to equal negative 10? And what you should end up with is negative 9 and negative 1. So I'm going to write x squared minus 9 and x squared minus 1. And what we have here is we have x squared minus 9 and x squared minus 1, which both are dots, difference of two squares, which means that we can continue factoring even more. So I can split apart the x to the x squared minus 9 into an x plus 3 and an x minus 3. And I can split apart the x squared minus 1 into an x plus 1 times an x minus 1, still maintaining that equals 0. Now, any part containing a variable will be set equal to 0. So we are going to end up with 5 solutions in this problem. If it helps for you guys to see that this first one is going to produce a 0 by setting it equal to 0, I don't mind showing you that. So we set 4x equal to 0, divide both sides by 4, and we find that x equals 0. And then it's the opposite of what we see on the inside. So the opposite of a plus 3 is a negative 3. The opposite of a minus 3 is a positive 3. The opposite of a plus 1 is a negative 1. And the opposite of a minus 1 is a positive 1. You can write your answers just like you see here, or you can write it as x equals 0, comma, plus or minus 3, and plus or minus 1. Both ways are absolutely appropriate. Let's go ahead and look at letter B. For letter B, we need this equation to be equal to 0, and we need the leading coefficient to be positive. So in this problem, our leading coefficient is already positive because hold on just 1 second, let it clear up. There we go. So we have 2x to the 5th power. That is our leading term because our largest exponent is 5 and it's already positive. So that means that I'm going to bring just 14x cubed to the other side because it must equal 0. That is really, really important that it's equal to 0. So now I'm going to rewrite this as 2x to the 5th power minus 14x cubed plus 24x is equal to 0. And now I'm going to factor out a greatest common factor because 2, 14, and 24 are all divisible by 2, and they all have a variable in it, and the smallest variable, or the variable with the smallest exponent, is just the letter x, so I'm going to factor out a 2x. The leftovers is going to be x to the 4th power minus 7x squared plus 12, and this is going to equal 0. From here, I'm going to break this trinomial apart into 2 parentheses, splitting apart the x to the 4th into an x squared and an x squared, and asking myself, what 2 numbers multiply together to equal positive 12, yet together add to equal negative 7? And hopefully you're able to see that it's going to be x squared minus 4 and x squared minus 3. Now, x squared minus 4, that's a dots. That's a difference of 2 squares. So that means I need to keep going with my factorization. So I'm going to have 2x times x plus 2 times x minus 2. And because minus 3 is not a perfect square, I just leave this as x squared minus 3 equals 0. So I can now set each piece containing a variable equal to 0, but I'm going to warn you, please, please, please be careful whenever your variable is raised to the 2nd power. I'm going to show you what that one's going to look like in just a second. So far I have x equals 0, and x equals negative 2, and x equals positive 2, but over on the side, I am going to set x squared minus 3 equal to 0, and I'm going to solve for x using square roots. I'm going to start off by adding 3 to both sides so that I can get x squared alone. It's going to equal 3. Now remember that to get rid of a square, you have to take the square root of both sides. And we'll end up with x equals not just the square root of 3, but plus or minus the square root of 3. Because whenever you take the square root of both sides, you have plus or minus in your answer. And so there are our 5 solutions: 0, plus or minus 2, and plus or minus the square root of 3. All right, we have one more example, and then we have team pair solos that I would like you to complete before the next time I see you. So looking at letter C, the term with the largest exponent is negative 6x to the 4th power. But because our leading coefficient is negative, I need a positive, so I want a positive leading coefficient. So that is really, really important. And I also have to have this equal 0. So therefore, I'm going to start off by adding 6x to the 4th power to both sides. Now, if 6x to the 4th power was already positive, I'd be bringing all of the other terms to the other side. And I don't care how many terms I have to bring over to the other side. I really need our leading coefficient to be positive, so that's really important. So now I have 6x to the fourth power minus 27x cubed plus 15x squared is equal to 0. 6, 27, and 15 are all divisible by 3, so I'm going to factor out a 3 as well as an x squared because my variable with the smallest exponent is x squared, and they all have a variable in it. So now I have left over inside 2x to the second power minus 9x plus 5, and this is going to equal 0. So now this is where I'm going to show you that trick again for how you can tell whether or not a quadratic is factorable. Now remember that if b squared minus 4ac is equal to a perfect square, then that means that it is factorable. So I am going to check that b squared minus 4ac is factorable in this problem. So b squared, that's negative 9 squared minus 4 times 2 times 5. And when I put that into my calculator, I end up with 41. 41 is not a perfect square. So what that tells me is that it is not factorable. And so because this is not factorable, how do you find your x-intercepts for something that is not factorable? Well, I can certainly find an x-intercept or my solution from 3x squared. That means that I would set 3x squared equal to 0, divide both sides by 3. I'd end up with x squared equals 0, square root of both sides, x equals 0 is what is produced from the 3x squared. But because this quadratic is not factorable, I have to use the quadratic formula. Now the quadratic formula, for those of you who may have forgotten it, remember that's x equals the opposite of b plus or minus the square root of b squared minus 4ac. This is all over 2a. So I'm going to write x equals the opposite of b, which is going to be 9, plus or minus the square root of b squared, so that's negative 9 squared, minus 4 times 2 times 5. This is all over 2 times 2. I already know what's going on the inside of my or underneath my radical. So I'm going to say x equals 9 plus or minus the square root of 41 because I already calculated it over here. This is all over 2 times 2, which is 4. So in this problem, I ended up with 3 solutions. 0 and 9 plus or minus the square root of 41 over 4. That plus or minus indicates that we have 3 solutions. And that is the end of this lesson. I would like you guys to please go ahead and try the team, pair, and solo on your own and be ready to discuss those for the next time that I see you. If you have any questions over anything I talked about in this lesson, please feel free to email me. Otherwise, I hope you have a wonderful day.